Good morning everyone. In this video, I'll be talking about type 2 diabetes, which is basically non-insulin dependent diabetes. I have already made a short video onto this. Now there is a insulin cascade, which is basically responsible for this whole type 2 diabetes thing. Okay, what is insulin cascade? The normal pathway is basically there is insulin receptor. Okay, there is insulin receptor on our cell. Now there is another thing which is known as IRS. IRS is nothing but insulin receptor substrates. Now in presence of IRS, suppose this is a IRS. Okay, this is IRS and this is insulin receptor. This one is insulin receptor and this is IRS, insulin receptor substrate. Normal cases, in the non-diabetic stages or situation, a healthy human being that has a normal thing, that is insulin receptor that have to bind with the IRS. Now for the normal thing, the IRS has to be activated by this insulin receptor via phosphorylation. Phosphorylation usually occurs at tyrosine residue of IRS. Okay, the insulin receptor substrate that has tyrosine residues, and onto the phosphorylation event, with the help of insulin receptor, IRS become activated. Whenever IRS become activated, it will further activates or it will communicate with a protein kinase which is known as phosphoinositide 3 kinase. Okay, phosphoinositide 3 kinase or PI3K. The short form is PI3K, phosphoinositide 3 kinase, that will be communicated with this phosphorylated IRS. That is the phosphorylation that occurs, or the tyrosine residue of this IRS. Remember this thing, tyrosine residue of the IRS. Okay, this is a normal cascade, and after that, whenever this PI3 kinase or phosphoinositide 3 kinase becomes activated, it automatically help to translocate GLUT4 receptor at our cell. GLUT4 receptor at our cell, which will in turn intake the glucose from blood or plasma, okay, into the cell. So it will take up whole blood glucose from the cell. So in this way, it will balance the blood glucose level in a normal situation, in a healthy human being. Okay, now what happens in type 2 diabetes? In case of type 2 diabetes, usually what happens, there is an insulin receptor, there is the IRS. Basically there is IRS 1 and 2, that is insulin receptor substrate 1 and 2. Okay, now there is also phosphorylation occurs, but not with this, not with the insulin receptor. Whenever insulin receptor that will binds and tries to activate this IRS, they generally phosphorylate the tyrosine residue. But in case of type 2 diabetes situation in our body, what happens? Insulin receptor cannot bind and activate this IRS 1 and 2. But phosphorylation occurs. How? Serine threonine kinase, another cascade, that is serine threonine kinase cascade, that in turn activate this IRS. But the residue is not the tyrosine at this time. That is basically the serine or threonine. Okay, it's not the tyrosine. So tyrosine is not activated due to the phosphorylation by this insulin receptor. Remember this thing, in a normal situation, insulin receptor that will phosphorylates the tyrosine residues of IRS, that will normally follows the whole insulin cascade. But in case of type 2 diabetes, another kinase protein, that is serine threonine kinase, in place of this insulin receptor, that will binds and phosphorylate the IRS, not at their conventional tyrosine but the serine threonine residues, which in turn cannot communicate with PI3 kinase, and in turn cannot translocate GLUT4 receptor. Okay, if PI3 kinase is not activated, so GLUT4 receptor also cannot be translocated, so blood glucose level cannot be internalized into the cells. It will remain into the plasma or the blood, and the blood glucose level become increased. Okay, by the time it become increased, so due to the fatty acids and all acetyl CoA, that will generally activate this serine threonine kinase, which will in turn activates this IRS1 and 2, not at their conventional tyrosine residues, but their serine threonine kinases residues. So due to that, the whole downstream process that become inactivated, and the blood glucose level that become increased at a higher level, which cause the hyperglycemia, and that will cause the type 2 diabetes mellitus, or also known as maturity onset diabetes mellitus. Hope you like this video. If you like, please subscribe my channel and share with your friends. And for more, you have to watch my channel, and I have already made videos on diabetes in the short form. If you like, please check my channel. Thank you so much.